Okay, so this is coming from your pyridine slides that you guys did previously. So we talked about pyridine functionalization a bit before the midterm, but we didn't get to finish it, so I'm coming back to that now. Okay, so one of the things that we finished on the halogen-Jantz reaction really and started talking about palladium catalyzed couplings a little bit. And so I gave you this kind of guide that of those common palladium catalyzed couplings, you're going to have ones that could be distinguished from each other. So the Stille reaction, for example, uses tin. That's how you can distinguish the Stille reaction. And it's a really good reaction. The problem is that organotin compounds are really toxic. And so, for example, organotin compounds are common pesticides, and anything that's a pesticide is a humanicide, basically. We're pretty similar to bugs for the most part. And it's also organotin compounds have been implicated in causing Alzheimer's. Whether or not that research has been really substantiated, I think the jury's a little bit still out on that. There is, but nevertheless, it's a really good way to form a carbon, an sp3, sp2 bond, carbon-carbon bond formation. There's the Suzuki reaction, and that is distinguished by using boron. The Suzuki reaction is great because it's a mild reaction and at least has been thought of as now as non-toxic, but now there's some data saying that some aryl boronates are toxic. So there is some question now about that. And by toxic, what I mean is that they're carcinogenic. There's the Sinaga-Shira reaction. This one is an alkyne coupling, so it specifically needs an alkyne as a coupling partner. And in this case, you need copper as one of your catalysts. And the last one is the Heck reaction. The Heck reaction is done with alkenes. And so in the next slide, you're going to click to video 1, and I'm going to show you the Heck mechanism. Okay, so there's some problems with pyridine-containing drugs. And one of the main problems is that they can bind to cytochrome P450 oxidase, this enzyme that we've talked about a lot, iron enzyme that is responsible for detoxifying a lot of compounds in our liver, detoxifying a lot of drugs, and the pyridine containing compounds can associate with it and inhibit it. And on this next slide, what I want you to do here is, on this next slide, click to video 2, and I'll show you a bit more about the liabilities of pyridine containing drugs. All right, so that's all for the pyridine slides. And so what we're going to do next is look at G. Jack Lee, read the chapter on the quinolines, and then watch the lecture on quinolines.